yeah, let's do it. So yeah, my name is Andre. My handle is Shazow, or Shazow as other people call me. And let's go. So, quick summary about this talk. First, I'm going to explain what WhatsABI is, just so you have a little bit of context. Specifically, how it's different from other tools, because there's a lot of different static analysis tools out there, and they do things a little differently. And more importantly, for the community here, I know you're all a bunch of security researchers and things like that. So the thing that I think will be relevant to you is I built some tooling to help me debug what's going on inside of EVM code. And that I think will be useful for y'all. And then I want to talk about where WhatsABI can go, because honestly, the stuff that I built I think can be used to solve lots of different problems. And I have my own kind of interests. And I'd love to hear how other people would use it, or honestly, like what other problems we can solve along the way, so we don't have to do one thing at a time. All right. So yeah, what is an ABI? I assume a lot of you know this, but maybe not everyone. So it is the acquired brain injury of what happens when you try to interact with a smart contract. But also it is an application binary interface. And what that means is when you have some arbitrary code that wants to talk with some other arbitrary code, but you don't know how it works, the ABI describes how to speak to it, basically. So it's this interface for applications to speak to each other. Traditionally, it's like a low-level C, FFI type thing, but in Ethereum's circumstance, it's some like JSON blob that we use to encode transactions so they can talk to each other. And unfortunately, you've already seen this joke because it got front ran, as it happens with MEV. Anyway, so WhatsABI is this project I've been working on for some months, and then this guy from Paradigm saw it somehow and tweeted it. It wasn't quite ready at the time, but I appreciate the early launch. And yeah, kind of the one line is deduce a contract ABI purely from bytecode, and that's actually one of the main distinguishing aspects. Is I don't look at any source code. I don't make assumptions about what it's written in. It's just purely from looking at the bytecode, which is pretty cool. And kind of how the way the project started, I needed to extract information from EVM bytecode, and my personal use case was I wanted to build a generative contract explorer. So kind of like Etherscan, but something that works with unverified contracts as well. And honestly, like something that can be a little bit nicer than Etherscan, such that normal people can use it, but we'll get to that. And the first step to that is just kind of getting some EVM and extracting the selectors that are in there. And then my other goal was to use static analysis. I'm assuming some of you might know what differences in static analysis and the dynamic analysis, but basically dynamic analysis is when you kind of analyze a program during runtime. So you give it some input and you kind of trace the opcodes it's executing basically along the way. And because Ethereum limits the amount of gas that can be executed in a transaction, you do end up eventually stopping, which is great. Whereas static analysis, you try to figure out what the program can do regardless of input. So you kind of look at how it's written, and so kind of a more complete way of doing it, you kind of execute every branch that the program can do, and you trace every possible way it can go, which means it can be infinite in a lot of cases, because unless we solve the halting problem, it's hard to know when to stop. And that's why a lot of static analysis tools you might be using often will crash or like time out or just like take a long time. And my difference in approach here is I want to strictly limit it to the order of number of instructions that are in a program. So I want to do only kind of a few passes of the code and not more than that, and just extract as much as I can from that. And it's been a really good constraint because I feel like I've actually been able to extract a lot more than I expected. And I think there's still a lot more we can do with just this constraint. So I think that's pretty cool. And then, of course, no assumptions about what it was written in, whether it's in Huff or just straight up assembly or in Viper and Solidity. it should always work. There's a bunch of tools that assume it's in some language and try to kind of bring it back to that language, which is cool, but I'm trying to kind of do things a little bit differently. And then the other goal is runnable in the browser. So I'd like these kinds of tools to be available in every wallet or in every dApp, so that we don't have to rely on some like backend that can tensor you or mess with your outputs and stuff. So I want everyone to be able to run this themselves. And then it's of course permissive open source, so you don't have to rewrite this yourself. You can you can all help build this and make it be all it can be. And yeah, so it's just a quick screenshot of the README to familiarize yourself. Don't have to read anything here. Don't worry about it. This is kind of like a really quick example of what it looks like, just so you have an idea in your head. You can extract the selectors from some bytecode. You can get kind of a JSON ABI from it. It even has some helpers for loading those hashes from a lookup index, of which there's a few. You probably know of the 4-byte directory and the newer open chain one, which basically is just like a big lookup database from hash to stuff that it hashes to. And yeah, and then there's one more function that I had recently, which kind of does everything for you at once, which is pretty cool. And just a little bit more context. It's only been kind of a few months, but it's already used by a few different projects. Gnosis is using it. Some explorers are using it. I think some MEV searchers might be using it because I've seen people contribute to it that seem to do MEV stuff, but none of their stuff is open source, obviously, so I wouldn't know. And I'm hoping security researchers will be able to use this. All right. So for those of you who haven't seen a selector jump table in EVM, this is kind of going to be a quick intro, just so you have a little bit more context about what we're trying to solve. This is some kind of high-level to the code. And yeah, all it does is it takes the input, which is called data load instruction. We strip out the last 4 bytes. We have a bunch of if statements. So if the selector is foo, then go to this function. If the selector is bar, go to this function, and so on and so on and so on. So it's not too complicated. And our goal is to extract those hashes so that we know what kinds of things a program does, because those hashes can tell us a lot. And then one more quick example. Imagine we have this kind of sample program. So this is on evm.codes, a really awesome playground. We can build it and get this kind of bytecode, and the kind of dotted lines are the hashes that we're trying to extract. So you can see those jump I instructions, each one is basically an if statement. So jump I will jump to an offset if the input is true. So it shoves some selector onto the stack, and it shoves the original argument on the stack using dup1, and then it checks if they're equal to, and that returns a 1 or 0, and then that determines whether jump I jumps or not. So you can see there's a whole bunch of them. And then we can take those hashes and we can look them up on a database, and we can see that it's increment and get and decrement. And that's kind of what WhatsABI does abstractly. And now let's dive in. So how do we do this? I've looked at a bunch of different approaches, and I'm going to kind of quickly catalog what they do and why they're wrong, and why WhatsABI does it betterer. The first one I've stumbled into, people just extract all the references to the push4 opcode and then assume that it'll have all of them, and it has a bunch of junk in there, and then they just deal with it. More commonly, I think SSL opens up and do this, and also Heimdall does this. You get all the push4s, and then you match it against some lookup, and you throw away everything that doesn't match. So you could see kind of a quick screenshot of the code for Open Zeppelin tool, where they just kind of loop over and look for the push4s and grab them. And similarly for Heimdall, I don't know how to say it. I'm sorry if I'm saying it wrong. Similarly here, they loop over some assembly and look for push-4 instructions and grab them and sort them and dedupe them and do all kinds of things to them. And there's some issues with this approach, which we'll talk in a second. But one kind of obvious way to improve it is like rather than just grabbing every push-4, which of course has all kinds of junk, we only grab the push-4s that are linked to a jump. So that kind of gives us all the values where we have if statements on that we're jumping on, which already helps reduce a lot of noise. And that was kind of my first approach. And then also someone tweeted out a project they did where they do that using a regular expression, which I thought was really cute. And that's kind of a great place to start at. But so what are all the issues with these? So this is kind of something I've learned by trial and error. I like my kind of goal. I did read some of the Solidity compiler and some like papers on this and how other people do it, but mostly I just try to reverse engineer things to be more objective about not caring about what it was written in. And what I discovered is there's a bunch of edge cases that I kind of addressed one by one as I ran into them on chain. So for example, you have all the push-4s, all the jumps. Well, there's a lot of jumps outside of the jump table. What do you do with them? And then some of them might even match up with the signatures of actual functions. So you have a lot of false positives that you don't want because that can mislead you about what things are doing. And then if you're not going outside of the jump table, how soon can you stop? If you stop too early, is there a chance you're going to miss stuff? Like what? How do the jump tables actually look like? I think naively, I wanted to assume that there'll be these like linear if statements, but it turns out that that's not always true. Because, for example, once jump tables get big enough, they get broken into trees. So, for example, Uniswap has a lot of functions, so they have kind of levels and levels of jump tables. If it's less than some value, it jumps to another jump table, and so forth. And then the other interesting thing is, which kind of in retrospect is obvious, but kind of blew my mind, is what if there's a 0, in front? Turns out we get a push-3 instead of push-4 because obviously that's an optimization, and Solidity loves to optimize. And then what if it's all zeros? So this is surprisingly common because the zeros are cheaper on chain than with non-zeros. And then people like the aesthetics of this. I think Seaport uses zeros. A lot of MEV people use zeros. Here's some examples of all the different known, not all, just a small subset of all the different function signatures that hash to zeros. So you could see some of them are kind of MEV focused. Some of them look like it might be a coincidence. Some of them were obviously mined with arbitrary suffix. But yeah, it happens. So if it's zeros, then the entire thing changes. Instead of EQ, is 0, and we're no longer matching them. And then there's like a few other questions, like what if the program counter is small enough to be push-1? At the moment, it's still a push-2, but maybe that could be optimized in the future. What if the selector is not 4 bytes? One thing I think people underestimate is like the nature of our selectors is kind of a social construct. It's something that we implicitly agreed upon based on Solidity. But in reality, there's nothing in the EVM that restricts you from using longer selectors or even shorter selectors. You can give it an integer and something, and it'll still work. Let's see. And then the last one, of course, is if you also want to deal with a NixOS, which is kind of a program inside of a program. So a NixOS literally generates the program you want to deploy, and then it returns it. So it often has its own little jump table, and then it returns a thing with a jump table. So that also is annoying to deal with. Just want to take a quick second. Anyone have any questions before I dive in how these are addressed? Let's see. Hello, everyone. Nope, I think we're good so far. Cool. All right. So What does what's ABI do? So we kind of generalized a lot of these. We don't look at push 4s or push 3s or push 2s. We just kind of look at all the different pushes. Uh, we work somewhat agnostically to the stack. So we have all these different variations. We deal with a 0. We deal with jump trees. We try to track jump windows, which is kind of tricky. So a jump window is kind of like a function scope. So normally in programs, when you kind of call a function, you know where it starts and where it ends. With EVM bytecode right now, until the upcoming EOF update, if that ever gets merged, there's no clear delineations where a function starts and ends. In fact, you can have disjoint functions. So like imagine you have a bunch of code, and then you have an unconditional jump to a bunch more code. And then in between, that's actually a whole different function. So that can happen, and it's kind of hard to deal with, but we do our best so far. We think we can do a lot better. We deal with non-standard selectors to an extent. Like if you go super crazy, probably won't match it, but at the moment, it doesn't care about the length or what they look like. And one cool feature, which I'm mostly here to demo, is the kind of the annotation and the analysis of the jump windows. By kind of organizing the jump windows, and I annotate them with interesting opcodes. So basically, I chose a list of opcodes that I deemed to be interesting. For example, sload and store can indicate to us whether it writes something or reads something from states, which will tell us if it's a view or if it's pure or if it's not. And then there's a whole bunch of other stuff like whether it reverts, whether it returns, whether it has a bunch of other properties. And then we also do some detection of static init code. You can have init code that is not static. I don't think it's super common. I haven't found good examples of it, but in theory, you could have init code that just generates the runtime code on the fly, which would be kind of cool, but I haven't seen that done yet. Maybe someone knows of examples that I can look at. So that's kind of the meat, and now I'm going to show you, or honestly, that's more the bread, and now I'm going to show you the meat, I guess. So there's some extra tooling that I built to help figure out why things weren't working, and basically I took all that information and I visualized it. It's eventually I would like to make kind of a web UI for it that you can play with yourself, but right now it's kind of buried in the GitHub repo. So if you clone it and it's under source bin, there's a few tools there. And what this does is takes a address, it downloads the VM bytecode from it, and it visualizes as a graph.file, which looks like this. You don't have to read this. You can load that into dot, and dot can spit out an SVG, and then you can open the SVG, and it looks like this. And you can kind of already start to imagine this being useful. So you see there's like a little fragment of code that will call into a bunch of selectors, and the selectors call other things, and you kind of get the shape of a program. And one of the interesting thing I noticed after looking at a bunch of these is a lot of programs look very different. So this is a really simple one that from like Solidity version 0.4 or something. And honestly, the older it is, the more simple it looks because there aren't as many optimizations. So this is a really simple one, but it's kind of a good example because now that we have these selectors on here, we can look them up and we can annotate them with what their names are, which is already makes it more useful to figure out what's going on. And then we can take that and we can annotate it with the interesting opcodes that was the thing that I mentioned earlier. So which of these window fragments call interesting opcodes? And honestly, this is kind of just a set that I personally chose, but you can add other ones in there. So we could see there's some S loads and reverts going on here. Here it looks at some of the data size and the actual call data. Here it doesn't. And as a security researcher, if you're evaluating kind of low-level bytecode, for some reason, maybe it's written in Huff or maybe you don't have the original source code, this is kind of a good way to figure out where to focus your effort. Like in this case, it's all pretty linear, but let me show you a couple more examples. So this is WETH. So you can see a few of these functions, they all kind of go into the same place over here. And then maybe there's something more interesting going on in one of these rather than over here where it's just kind of, probably before it's just organizing the data to look a certain way, and then it's actually doing the interesting stuff underneath. And then this is Seaport. You can see it's already getting more complicated. This is just a small subset of it. I couldn't fit the whole thing on the screen. But yeah, this one, all kinds of lines going everywhere. I want to add more interesting metadata in each one so we can figure out what's going on where. And then this is Seaport 1.4, which also looks different. But yeah, it's cool because you could see where all the different selectors are and such. Yeah, so that's the tool. I would like to give a live demo. Does anyone have any contracts they want to visualize? Let's see, how are we doing? Anyone have any questions? Otherwise, I'll just load up some random ones and we can go through them. And then I have a couple more slides after. All right, I'm going to give it 3 more seconds. All right, I'm going to go with some random contracts. All right, so all right, so here's what I did. I can show you some common ones. So the beacon chain, for example. This is the beacon chain. Whoa, it's tiling. How do I stop it from tiling? All right, hope you all can see this. Yell at me if you can't. So you could see it has the deposit function, the deposit route. It's a very vertical one. Most of them are fairly horizontal, but it kind of chains down. Clearly, the deposit function does the most. The other thing to keep in mind, my code is still imperfect. I'm missing some branches. I'm primarily looking at static jumps. I haven't gone to the dynamic jumps that rely on the stack to evaluate where it's going. That's coming up. So you can sometimes get these kind of dangling ones that are probably linked somewhere, but I just missed it, unfortunately. So yeah, don't assume that this is 100% accurate. It's kind of a subset of accuracy. But yeah, this is what the beacon chain looks like. Oh, all right, okay, some random MEV. So I don't know if this is MEV bot. So what I did is I go to Etherscan, I look at the latest block, and I look for any contracts that aren't verified, and I just try to look at them just to see what they're like. So this is one I found that's not verified. What did I look at? So it's yeah, basically, yeah, this one. So it's unverified. You don't know what it does. It calls up these methods. We don't know why. And then we open it up. Where am I? Sorry for jumping around. Do it again. And it looks thusly. So yeah, it has some functions that we know about. It has an owner function, obviously. It has withdraw dust function. It has admin function. It has some function we don't know about. We could try to reverse these by brute forcing them if we want. Release gas. I'm pretty sure, I don't know. Yeah, transfer ownership. Yeah, so this is a random one that I found just now. Let's see. Let's do one more random one. Transactions. Find one that doesn't have names real quick. Also, feel free to drop your favorite contract in the chat and I'll run it. All right, so this one, for example, 7 seconds ago, we don't know what it is. It's unverified. Let's see, grab this address. Shove it in here. I have a bunch of caching here because I keep doing this a lot and I didn't want to spam the APIs too badly. All right, let's look at it. So, similar idea, set withdraw wallet, remove allowed token, last block, draw token, routers. So yeah, this could be an MEV one, hard to tell. It does store a lot of things. Yeah, it looks like it has routers, remove routers, has withdraw. Yeah. So yeah, stuff like that. And then like let me run through a couple other ones that are known. So yeah, this is like the optimism gateway, for example. Whoops, I just locked my screen. Excuse me. Cool. Yeah, you can kind of see it has a different shape. Yeah, I mean, personally, I just like how all these contracts. Oh, there you go. Someone has one I want to try. I like how they all have different shapes, and the more resolution I kind of get at them, the more visible the differences in the shapes are. And I feel like just kind of on a gut level, the shape of a contract can kind of tell us a lot. All right, let's try the one that was shared in the chat. Cool. That's all we got out of it. Nothing. I wonder why. Is it a proxy? I don't do proxy resolution yet. I need that's on my list as well. Let's quickly look at what it is. It actually has stuff. Cool. I'll add that as one of my test cases that doesn't work. Thank you. Yeah, if anyone stumbles onto things that don't work well, please share them. And yeah, I mean, it just anything that's EVM. So if you can give it the bytecode, it'll load it. My little tool doesn't know how to fetch code off of mainnet, but I can pipe it in, I think. Let me see. You can do dash, and then you can pipe it in, I think. Ugh, sorry. Some code. I'm gonna pipe it in. Just making sure it doesn't have an extra space. Some code. No, okay. I think I messed up the encoding somewhere. All right, in theory, it should work. In practice, might need to clean it up a little bit. But yeah, in theory, you can pass in arbitrary code like that. It'll work. I'm sorry for jumping around a bunch. Let's see. All right, let me do one more. All right. Boom. Oh, I actually have another tool called bytecode that just dumps the more readable version of the bytecode using uploads. Okay, there we go. So this is the one that someone said Heimdall didn't help him with. Hopefully this is a little more helpful to some extent. So we have, at least we know what some of the operations are. We kind of know how they all talk each other through this interesting common function. Okay, so let me show you the other tool. So we have OX5318, right? I'm going to go back here. I'm going to sleep this and regret it. So I have this other tool called, where is it? Called bytecode. Let me make this bigger. So by default, it's just going to dump the opcodes, how I'm used to reading them, which is fine. A lot of things can do that. OX5318. 5318. And this is going to dump kind of the surrounding instructions after that jump destination. So you can kind of inspect what it does. And what I would like to do is I want to build kind of a web front end for this so that you can click on it and it'll just show you the relevant bytecode. So you don't have to kind of jump around back and forth. And I think that'd be super useful. But yeah, this was able to extract all the selectors from it. It even got the names for some of them. Didn't get the names for others. We can improve on that. Let's see. Yeah. Cool. All right. So let me finish the slides, and then maybe we can do some more demos. People get ideas. And yeah, the future. So what I want to do with this, I want to parse deploy netcode, which is something I just added. And kind of the problem there is usually when you use the get code Web3 API, it just returns the deployed code, the runtime code. But if you pipe in something that's been compiled, you're going to get the init code, which is kind of annoying to split up. So this will parse the static init code and split them up, and then you kind of have a program inside a program, so you can actually inspect them separately, which is kind of cool. I want to detect common interfaces. This is super useful, I think. So for one, obviously, is for proxies, is detecting when it's a proxy, and then also having a helper for resolving proxies on the fly. That shouldn't be too hard. I just need to do it. The other ones is I was going to scrape basically all the common libraries, so like Soulmate and OpenZeppelin, and extract all the interfaces they define and be able to kind of say it's this interface or that interface, or it implements these interfaces. And I think that would be super useful for analyzing what different contracts do as well, just by knowing what interfaces they implement. And it's also good for building explorers too, which I would like to do someday. This is a hard one, and a really useful one is abstract stack tracing. A lot of other tools already do this, but they have other limitations. And basically what this is since we're doing static analysis, we can kind of keep track of abstract inputs, so like inputs that we don't know what they are, so they're kind of placeholders, and we just keep track of their position on a stack, and that way we can separate out the hard-coded kind of explicit inputs versus the abstract inputs, and we can also tell what operations are done on them, and we can tell how many there are. So for example, we can tell how many inputs a function consumes, which tells us how many inputs it requires. And we can tell what kind of operations are done on it, which might inform us whether it's an address or a uint or something else. So this abstract stack tracing is super useful. And I've started on this, but that's going to be a fairly big project. I'm also tentatively looking for some grants if anyone has any contacts to work on this, because I think it's going to be a decent chunk of work. And of course, once you have abstract stack tracing, we want to detect the input types and the output types as best as we can. Right now, we detect whether there is an input and output in some cases just by looking at which opcodes are used. So if we load inputs or we do a return, we assume that there's an input or an output. And I have placeholders that just define kind of an arbitrary number of bytes without actually trying to figure out what it is. Better function window detection. So especially for dynamic jumps, with abstract stack traces, we'll be able to get more of the dynamic jumps into the window detection, which will be really useful, and it'll make a more complete graph. I would like an interactive call visualizer, which is the thing I mentioned, kind of like a web-based UI for the thing I just demoed, where you can kind of jump in to different functions. I'd also love for it to work across different contracts. So if you have a contract that's like referring to another contract, you can jump across them, which would be really cool. And then kind of a moonshot, someday I would like semi-dynamic analysis. So we do all this we transform the bytecode into this internal representation of static analysis, and then we can use some aids to kind of run through it. So for example, we can look at on-chain transactions to that address and see how they behave to kind of extract even more information from that without actually doing full dynamic analysis. That could be really fun. And yeah, that's it. This is the end. This is the repo. This is how you import it. This is how you reach me. I'm Shazow everywhere. .net, not .com or .eth or whatever. I'm Shazow on Twitter, Shazow on Firecaster, Shazow on Discord. Yeah. Any questions, requests, feels, thoughts?
Yeah, Supernova had a really good point. Is this tool available for security researchers to use in their audits? And if so, where can they get their hands on it?
Yeah, I mean, absolutely. It's all open source. It's on GitHub. Search for WhatsABI. It's all there. I would like to make it better. So if you try to use it for security research and you want to tell me, thank you for linking, and you want to tell me what would make your life easier or what would be a really high value improvement for you, please do. Feel free to open an issue or just message me, and we can prioritize accordingly.
Nice. And Moise had a question. What are some of the considerations when designing an ABI to be runnable in a browser?
I mean, the ABI doesn't care where it's running, but having this tool run in a browser, for one, so my original version of it, so I built this in TypeScript, and I used a bunch of dependencies to just make it, the original version, really easy to build. So I've used this other disassembler. And unfortunately, it used Node APIs that don't run in the browser, for example. So I ended up getting rid of it and just writing my own disassembler. And now everything runs in the browser and it's easily embeddable. So that's one thing. The second consideration is it has to be pretty fast. So like relatively low computational complexity. Like we don't want the situation where someone hits a button and then their thing just like runs out of memory because it just gets stuck in an infinite loop. So having a fixed number of instructions that we limit ourselves to really helps. I think those are the two big ones. Yeah, I mean, so the other half of the reason why I did this is I wanted to learn the EVM better. I have a bunch of ideas I wanted to build an EVM, but my understanding of the actual underlying kind of assembly was fairly weak. So the way I learn is I think of a thing to build that requires learning the thing I want to learn. So that was the other half of the reason. So yeah, I mean, my main recommendation for people that want to learn something is like figure out what you are excited about to make that requires learning that, and then that's very motivating. um, yeah, unfortunately, ChatGPT was not very useful, so I'll tell you that. Oh, I beat you to it. You got front run, my friend. Yeah, I mean, I experimented a little bit. I'm sure it'll get better. It knows what opcodes are. It knows what they do, but it doesn't know how they interrelate or execute each other. So it was not super useful for that. Like obviously, EVM Codes is a super useful website. Everyone should have bookmarked. That's a great place to start because it has a little playground where you can run EVM stuff and also see what all the opcodes do. Yeah, what other cool things can I tell you? Yeah, I mean, so the thing that I'm super excited about, which I mentioned, is I want to build a procedural contract explorer. And my vision is I want a thing where most smart contracts don't need their own UI. So like right now, if you're building a smart contract, you also have to build a like a DApp UI for it because that's the world we live in. But I feel like 80% of them shouldn't need their own UI. You should be able to use some kind of like generalized thing that just looks at your ABI and just makes you a UI. So like if it's an NFT, it just builds you a little NFT UI. If it's like a swap router, it builds you a little swap router UI, and then you just use that. And among other things, one of the cool properties of that is it makes phishing attacks much harder because if you're not relying on every contract having its own UI, you can just use some like local running app to interact with it. It's much more safe. You could do much more interesting analysis and like and other kind of other kinds of safety tooling. Ideally, it would be built into some wallets like MetaMask, but I think that's a big ask. Yeah. What else do people wanna? So I kind of noticed like a lot of NFTs have a similar shape. A lot of DeFi stuff have a similar shape. A lot of MEV stuff have a similar shape. And I don't have kind of a thesis about what shape a contract should have yet, but I feel like there's going to be something there eventually once we get kind of a very high quality graph. All right, let's do one more. Tornado Cache. Ooh, spicy. All right, screen share activate. You can see me hopefully not violate a sanction. All right, Tornado Cache. Up. All right, here we go. Hope everyone can see a screen. Infura did not block me. That's already a good sign. Cool. Well, actually, yeah. So Tornado Cache was actually one of the kind of use cases that I was thinking for my procedural UI generators. Is that when it got blocked, I was thinking like, what would it take for a procedural generator to be good enough to be able to figure out how to interact with Tornado Cache? And that's kind of a really hard problem because Tornado Cache does a lot of stuff on the client to do all the extra crypto stuff. So it's trying to figure out kind of how do you encode that behavior in the source code maybe or somewhere else where it can be like defined on chain and then these procedural generators can like load it up and give their own interpretation of it. That'd be really cool. But yeah, this is what it looks like. Hope that's It definitely has a certain shape to it. What other fun ones are there? Yeah, you're welcome. Yeah, feel free. I'm on the Discord. If anyone wants to reach out, has more questions, wants to see more demos without running it themselves, or just go run it yourself. Thank you, everyone. You've been great.